Hi, I'm Doug Black. I'm editor-in-chief at Inside HPC. And today, as part of our Hyperion research series of interviews, we have no less than Hyperion's CEO, Earl Joseph. Earl, welcome.
Oh, very much.
Okay, so I thought maybe we could just start off if you could refresh our recent memory about the history of Hyperion and leaving IDC to become an independent industry analyst firm.
Sure, thanks. So we originally were part of IDC, this group, for over 30 years. And at IDC, we did all the different market research things, trying our best to track everything sold every quarter, following all new technologies and everything else. But then IDC was sold to a foreign owner. And because we do a lot of things for the U.S. government, a lot of things for R&D for U.S. industry, we weren't allowed to be under foreign ownership. And that was the motivator for us spinning off almost 4 years ago. And so when we spun off, we were fortunate in that IDC had to give us all the IP related to high performance computing, all the research documents, and our entire footprint actually had to be removed from IDC. So it was kind of a fascinating process to go through.
Okay, so maybe you could give us a profile of Hyperion and its, your unique strategic methodology.
Sure. So one fortunate thing we have is we brought with us most of the approach that we used at IDC, and that made our life a lot easier as far as trying to design a company. And first of all, we try to study what's going on in the world at a given point in time. And what I mean by that, in a given year, we do between 20,000 and 25,000 individual survey interviews. So we're interviewing the community, the vendors, the suppliers, and we try to really understand all the dynamics. And as I mentioned, we do try to track everything sold, but every technology area we maintain forecasts, 5-year forecasts in each area. And the fun part of the job is we get to work with all the different HPC organizations around the world. And we spend about half our time with users and half the time with vendors, including helping various governments develop their HPC plans, strategies, and their approach to the world. The other thing we get involved with a lot is trying to justify the purchase of supercomputers. As you know, the cost of a supercomputer has grown dramatically, and so the approval process is much more complex than it has in the past.
Right, I'm sure that's a huge effort on that score. So within your overall knowledge of HPC, what are the particular areas that you focus on individually?
Right. So, fortunately, as CEO, I get involved in kind of all the projects we're doing. But my major involvement is with the different government organizations around the world, the intelligence communities, the military is also on that portion. Also, because I have a mechanical engineering background, I get involved a lot in the manufacturing sectors of the business. But I get involved heavily in the design of our studies, kind of ensuring the quality, helping doing a number of the surveys, and then a lot around the numbers. In order for us to do all the studies we do in a given year, we're probably doing on the order of 25 to 30 custom studies, in addition to all the base work we have to do. For example, we have to publish over 100 documents a year on all different topics. And so I spend a lot of my time trying to do quality control to make sure everything's consistent, that all the things tie together. And in the past, when we would do 4 or 5 studies a year, it was pretty easy to keep all that in memory. And I have to tell you, 25 to 30 separate studies a year, it's very, you have to constantly look up to make sure, does this number tie back with this study, or how has it changed? And the dynamics are just unbelievable right now. For example, in cloud computing, we do about 10 studies a year. On AI, we're doing 6 or 7 separate studies a year because it's just changing so quickly. And that's the fun part that I enjoy.
Yeah, cloud HPC, of course, is exploding, as you've been reporting. So, looking back over the last 5 or 10 years, what would you say are the biggest changes in HPC that you'd say have had the most impact?
The ones that have had most impact, I think, is using HPC to solve what I'll call national problems. And for example, and that is to make countries more innovative. And we've gone through some difficult economic times. If I look back a little bit more in 5 years, but maybe 8 to 10 years, we've gone through some very difficult, economic times. And a lot of countries have decided that to get out of the economic doldrums or problems, as a nation, you have to be more innovative. You have to be more competitive, and you have to protect your manufacturing by being competitive. And so these countries are using HPC to address those really large national problems. Now, in order to do that, that means instead of having just one giant supercomputer that you can brag about, each country needs multiple computers that are tailored for each one of their needs. And so that's a major trend that we're seeing. The second trend that we're seeing is somewhat related to that is the value is so high, people are spending a lot more per supercomputer. If you think back 15, 20 years ago, for $35 million, you could buy the largest computer in the world or, be in the running for that. Then it moved to 100 million fairly quickly. And now we're in a zone where you have to spend between 200 to 300 million to have the largest machine. And in just a year or two, that's going to be 500 to 600 million. So you think of Moore's law, the scaling of the processors, then on top of that, or the speed up of processors, and then you add that to the scaling of having a lot more in a system. And then when you scale your budget at the rate I just described, the power of the systems are growing just dramatically. And it's just amazing what can be done. And the exciting part to me is then when you take the traditional HPC technology, you add big data, AI with its machine learning, deep learning, graph analytics, the new abilities to discover new things is growing dramatically. And that's exciting to me.
Okay, great stuff. So where do you think HPC is headed? Are there trends that have you particularly excited or concerned as we move forward?
I think I addressed the biggest concern is the cost of the systems. The exciting part to me is all the new technologies. And I mentioned some of the AI ones, but also quantum computing, new types of processors. We're tracking right now over 200 different new processor designs. A lot of them are very highly specialized processors. But if you think of what a system could look like in 4 or 5 years, you may have a quantum computer, or maybe a couple of them, doing some part of the task. You could be acquiring massive data sets, and then you could have massive exascale machines doing a lot of the processing. Now, the interesting thing to me is when these technologies really come on board, and I'm not saying that AI isn't on board right now. I'm referring to when AI becomes more pervasive and uses gigantic data sets that might be 10,000 larger than today with a lot more quality. We may be talking about HPC systems that are in the tens of billions of dollars. When you talk about the whole data center, because you may have, if quantum computing works, why would you only buy one? You might want to buy 2 or 3 of them. If your data sets are great, you may acquire just massive storage farms. So I think the exciting trend on the horizon is the trend of the increase in size, the increase in science accomplished is going to continue to accelerate. And along with that, in the shorter term, just adding big data with AI, machine learning, deep learning to HPC, and combining the two together, I think will accelerate science and create actually perhaps a whole new category of research.
Exciting stuff. So Earl, tell us, how did you get involved in HPC in the first place? Can you summarize your background in the industry?
Sure. So it actually started when I was quite young. My father was a computer architect at ERA, and then that turned into UNIVAC. And so as a child, he was always giving us puzzles, problems to solve, and always around dinner was talking about the latest technology, the new developments going on. So back in a very early age. And then at the University of Minnesota, my PhD research was in the strategic management of high technology. And at that time, I wasn't certain if I was going to go in the computer industry because my father was very strong in the computer industry. And then I did decide that was the path to go. So when I graduated, I started at Sperry UNIVAC. And at Sperry UNIVAC, it was a really interesting job. It was good for me to start with a very large company because you saw is all the different problems, all the pieces needed, to make something successful. And I was fortunate to be in the development organization and actually running a simulator that simulated all 200 different product lines that the company had. Back in those mainframe days, mainframe company, not only did they make the computer, they made the terminals, the wires that connected it. And the fun thing with Sperry, before the days of the internet, Sperry actually had its own satellite system. It was called Sperry Link, and that's how they actually did their communication around the world in the systems. And then in the later 1980s, I joined Cray Research. And if I can tell you a little fun story, is when I was doing my interview at Cray, I was interviewing Ed Macy. I don't know if you remember Ed Macy at all, but it was over lunch, and he definitely is a salesperson by background. And about the middle of lunch, I realized he was about to give me a sales pitch, and I bet you I'm going to really like it. And his sales pitch was, let me tell you about Cray. this is where you find Cray computers. And he went through a list of all the advanced research in the world, you know, what's going on at CERN, the best weather forecasting, the best car design. And I was, you know, into the HPC industry full time at that point. And I did some things with the scientific processors, but it was really when I joined Cray in the late 80s. And so that's really how I became one of the HPC folks and joined the community.
That's a great story. I actually knew Ed Macy back when he went over to Intel to run their supercomputer systems division. So
Oh, excellent.
that's right. So that's great. Okay. So is there anything else we didn't cover that you'd like to add?
Well, this one thing I'd like to thank you very much and Inside HPC for doing the video series. We really appreciate that. But one very important thing I would like to mention is I loved working with Rich Bruckner. He really was a star and a really truly thoughtful, kind person, enjoyable person to be around all the time. And we really deeply miss him. And so we're sorry to see that him passing away this year.
Well, we miss him very much, and certainly at the conferences and his overall presence. So thanks very much for that, Earl.
Sure.
And thanks so much for your time today.
Great. Thank you very much for taking the time.